Hello and welcome to EduSathi. We'll be discussing the topic of quantitative reasoning for GRE and GMAT in this lecture. We'll start with the topic of arithmetic, and in arithmetic, we'll start with classification of numbers. So let's get started and let's look at numbers. Numbers can be classified into real numbers and imaginary number. So a number can be classified as either real or imaginary. To distinguish between the both, I need to understand what do you mean by real numbers. All the numbers that can be represented on the number line are known as real numbers. In fact, the number line is also known as real number line. So all the numbers that can be represented on the number line are real numbers. Those numbers can be in fractions, can be integers, can be negative, can be positive. We'll discuss about them in detail. And imaginary numbers. Imaginary numbers are the numbers which cannot be represented on the number line, or the numbers whose square root or cube root or nth root is not possible. So if I have to look at it, if I look at square root of 4, which comes out to be 2. But if I look at square root of minus 4, which is what? It is not defined, or it is not possible. In fact, I write it as 2 iota. What is iota? Iota is an imaginary number. So negative numbers under the root would be classified under the category of imaginary numbers. For our purposes, we'll be only dealing with real numbers. So real numbers is what we'll be concentrated on and not on imaginary numbers. So let's discuss about real numbers now. As already told, real numbers can be either negative or positive. So if I talk about real numbers, I would further categorize them into two parts. One being the rational number, the other one being irrational numbers. So real numbers further can be classified as rational or irrational. Rational numbers, a number that can be represented in the form of p by q, where q is not equal to 0 and p and q are integers, are known as rational numbers. So any number that can be represented in the form of p by q. So for example, if I talk about 5 by 7, if I talk about 2 over 3, if I talk about 7 by 3, if I talk about 10 by 1, or if I talk about 100 by 1. All these numbers can be expressed in the form of p by q. It could be minus 100 also, minus 10 also. It could be negative or positive, where my denominator should not be equal to 0 is a rational number. Talking about irrational numbers, if I go by definition, would be numbers that cannot be expressed in the form of p by q. They are not equal to the form which is p by q. That means they cannot be written in a form which is numerator over denominator. I cannot write them in this form. For our understanding purposes, we'll remember only this thing for irrational numbers. What is that thing? Non-terminating and non-repeating decimals cannot be expressed in the form of p by q, and therefore non-terminating and, this and is of utmost importance here, non-terminating and non-repeating decimals would be categorized as irrational number because they cannot be expressed in the form of p by q. Some examples that I need to remember are something like root 3. The value of root 3 is 1.732 and it goes on and on and on. The value that I get is non-terminating. Non-terminating means it does not end, and non-repeating. That means there is no pattern which is observed when I calculate the value of root 3. Similarly, pi. Now, pi equal to 22 by 7 is just an approximate value. 22 by 7 is a rational number, whereas pi, which is exactly equal to 3.14 and it goes on, is an irrational number that we have. Similarly, the value of e, all of these would be categorized as irrational numbers. Let's look at the number line. Now we were talking about real numbers now. Real numbers were classified as rational and irrational. So that means both rational and irrational numbers can be expressed on the number line. So I can express both of them on the number line. Now what is a number line? Number line is a line on which the numbers can be represented that extends from minus infinity to plus infinity with the middle value equal to 0. All the values on the left side of 0 would be negative, and all the values on the right hand side of the 0 would be positive. So 0 is neither negative nor positive. It is a neutral value that we have. All the digits, all the numbers, integers, fractions, whatever you want to call them, on the left hand side would be negative and everything on the right hand side would be positive. So if I just look at it, minus 1, minus 2, minus 3, minus 4, all of these are integral values which are to the left of 0, therefore they are negative. Whereas positive 1, positive 2, positive 3, positive 4 would be on the right of 0 and they would all be equally spaced. The distance between 1 and 2 would be equal to the distance between 2 and 3 would be equal to the distance between 3 and 4. Now the value of irrational numbers that we looked at, which was pi and e and minus pi, could also be represented on the number line. In fact, the roots also can be represented on the number line. The only numbers which cannot be represented on the number line are imaginary numbers, which are out of the scope of our examination. So we'll be looking at only real numbers. Let's look at some of the questions related to number line. Which of the following is farthest from the number 1 on the number line? So whenever you have a question of this type, you can look at a number line which has 0, you have minus infinity, and you have plus infinity on this side. Now what I'm looking at a reference point which is number 1. Which of the following is farthest? Farthest means the distance from the 1 has to be the greatest on the number line. So what I'll do is I'll just look at these numbers. Now if I look at it, any number on the right hand side that I'll plot would be positive. So what are the numbers that I have? I have 5, I have 10. And any number on the left hand side, so it'll be minus 5 on this side and minus 10 on this side. Now if I look at the distance, farthest, it is not asking me positive or negative, it is asking me farthest. That means the distance between 1 and that number has to be the greatest. Now if I look at 1 and 10, the distance is 9 units, whereas 1 and minus 10, the distance is 11 units. So my answer would be option number A. In fact, if you want to find out the distance, you can subtract the two numbers. So highest minus the lowest. 10 minus 1 would give you 9. And if you look at it, 1 minus 10 would give you a number which is 11. So the distance between 1 and minus 10 is 11 units, whereas the distance between 1 and 10 is 9 units. So you can subtract the highest from the given number to find out the distance. Let's look at another question. The question that we have is, on a number line, A is 6 units from B. Now, the only thing which is given to us is the distance. It is not given to us that whether A is on the left hand side of B or the right hand side of B. So A could be anywhere, could be on the left hand side or could be on the right hand side. The only thing which is given to me is the distance. So if I talk about B here, A is 6 units from B. So A could be here. This is again a distance plus 6. A could be here. The distance is 6, but I'm just writing it on the left hand side or on the right hand side. So the distance is 6. And B is 2 units from C. Again, B is 2 units from C. C could be either ways. C could be here also. So that means this is 2 units. C could be here also. This is again 2 units that we have. What is the distance between A and C? So that is the question that we have. These are the various possibilities. Whenever you have a question of this type, you have to look at all the possible solutions that can be there. And let me tell you, the highest probability of getting the answer is this, because if you look at it, wherever you get cases, there might be two or more answers to that. So if I look at A and C, this distance was 6, this distance is 2, that means this distance would be 4. If I look at between this A and this C, this total distance was 6, this distance is 2, this distance is 4. But it could be possible that A is here and C is here. So if I look here, this distance is 6, this distance is 2. So the total distance between A and C comes out to be 8 units. My answer would be option number D, 4 or 8, because it will depend upon which side is A located with respect to B and which side is C located with respect to B. Now let's look at another question related to number line. On the number line, the tick marks are equally spaced. Which of the following statements about the numbers x, y, z must be true? And the question says, indicate all such statements. All such statement means I will have to look at each of the statement and see if the statement is true or not. Now, an easier way to do this type of question is assume the value. Since all of these points are equally spaced, I can assume the values and get to a very easy answer. The distance between x and 0, 0 and y and z would all be equal. So in easier ways, just assume the values and get to your easy answer. The thing that I have to keep in mind is the value of x would always be negative since it is on the left hand side of 0. The value of y and z would always be positive since they are on the right hand side of 0. So if I just look at the first statement, this will be minus 1 into 1 into 2. If I look at the answer, which is minus 2, obviously minus 2 is less than 0 because minus 2 is negative. So the first statement that I have is definitely true. Look at the second statement. Minus 1 plus 2 gives you an answer which is plus 1, which is actually the value of y. So statement number 2 is also correct. Looking at statement number 3, it is 2, 1 minus minus 1. So it will be 2 into 2, which is 4, which is definitely positive. So I'll have third equation also holding true. So all the statements that are given to me are true. So my answer would be statement number 1, statement number 2 and statement number 3 all are correct. Let's move ahead and let's look at rational numbers now. Rational numbers, as already explained, are the numbers in the form of p by q where q is not equal to 0. They can be classified as integers and fraction. Now, if I fix the value of q is equal to 1, I will have my denominator fixed as equal to 1. So, I will only have the numerator divided by 1, which gives me an integer. So, when q is equal to 1, I will have no decimal or fractional value associated with the number. So, 10 by 1, 5 by 1, 4 by 1, or if I simply write it as 4, all of these are integers. They can be negative as well. The only thing that I have to keep in mind is my denominator is 1, so as I get no decimal associated with the number. If q is not equal to 1, if I have a certain denominator associated with it, and I have to take into consideration that the numerator and denominator should not be cancelled out with. That means numerator should not be a factor of denominator. All such numbers would be termed as fractions. So all of these numbers would be termed as fractions that I have. Fractions can be further classified as the ones which terminate but do not repeat and the ones that do not terminate but repeat. So they terminate. If I solve this 0.25, they terminate but they do not repeat, and 1 by 8 is 0.125. And the second one is they repeat but they do not terminate. So it has to be either one of the things. Either they have to repeat, not terminate, or they have to terminate but not repeat. If it's a case where it is non-terminating and non-repeating, it will be an irrational number that I will have. It will no more be a part of rational number, because in that form it cannot be represented in the form of p by q. Let's look at the fractions now. Fraction, as already stated, is a number in the form of p by q, where p refers to the denominator and p refers to the numerator and q refers to the denominator. Now this q cannot be equal to 0, cannot be equal to 1, and p should not be a p should not be a multiple of q. Now, in case I have to do addition and subtraction in case of fractions, I will proceed with this method. So, let's look at an example. 1 by 3 plus minus 2 by 5. I'll take the LCM, which is 3 into 5, and I'll solve the numbers with using the LCM. This will be 5, 1 into 5 minus 2 into 3. So, 5 minus 6, which will be minus 1 over 15. This is how the addition or subtraction needs to be done. In order to do multiplication, what I would follow is 10 by 7 into minus 1 by 3. I'll multiply numerators with numerator and I'll multiply denominators with denominator. So 10 into minus 1, 7 into 3. This will be minus 10, my final numerator, and 21 as my final denominator. Now, in case of division, 17 by 8 divided by 3 by 4, it is actually a case of multiplication if I just switch these terms. So it's the case, I'll just explain, a by b over c by d. It is something like numerator is a fraction, denominator is a fraction, and I have to divide the two. It will be equal to a by b into d by c. So I'll just switch it over. It will be into 4 by 3. Again, I'll multiply the numerators and I'll multiply the denominators to get the final numerator and denominator. However, in this case, my common factor would be cancelled out to give me an answer which is 17 over 6. Let's look at an example related to fractions. Which of the following numbers have a product that is between minus 1 and 0? Indicate both the numbers. I have to mark both the numbers. Now look at it. Between minus 1 and 0, product A and B should be between 0 and minus 1. That means the product would be a negative thing. Negative product I can only get if one is positive and another is negative. So one number has to be positive and one number has to be negative. Also, if I look at it, the product is between 0 and minus 1. So that means it is a fractional value, which is, if I look at the magnitude, it has to be less than 1. So if I look at it, these two numbers which are given to me are negative, these two numbers which are given to me are positive. So it has to be one of these numbers and one of these numbers. Now if I look at 2 raised to power minus 4, it will be 1. If I just convert it into the fractional part, it will be 1 over 2 raised to power 4, which will be 1 over 16. 3 raised to power minus 2, which will be 1 over 3 square, which is 1 by 9. So if I just multiply, if I just look at this minus 20 into, now if I look at it minus 1 by 16, it will be a number which is more than 1 in terms of magnitude, because numerator is more than my denominator. So if I look at the other one, which is minus 10 into 1 by 16, this will be a number which will give me an answer which will be negative, and the magnitude would be less than 1, because my numerator is less than the denominator that I have. So my answer would be minus 10 and 2 raised to power minus 4. These two would be the numbers which when multiplied would give me a product which is between minus 1 and 0. Let's look at the concept of mixed fraction now. Mixed fraction means I have a number like 2 1 by 2. It can also be written as 2.5 or 2 plus 0.5 or 2 plus 1 by 2. So A, B by C can be written as A plus B by C. The same can also be written as taking C as the denominator. A into C plus B. So I can write it in any form depending upon what is required to me in the question. So let's look at the example that I have. I have to add three mixed fractions. Now instead of actually taking an LCM and solving it out, I would separate the integer part and the fractional part. So integer part is 3, fractional part is half. 4 integer, 4 by 5 fractional. 9 and 1 by 3. I can add up all the integral parts to get to a final integral parts, which is 3 plus 4 plus 9, which is 16. And I can add all the fractions separately. So I am adding up 1 by 2, 4 by 5 and 1 by 3. Now for these three, I will take an LCM which will be for 2, 5 and 3. So 2 into 5 into 3. So I will take an LCM. So 2 is already gone. It will be 5 into 3, 4 into 2 into 3 and 1 into 2 into 5. So if I just work on the numerator part of it, it is coming out to be 49 divided by 30. So if I look at it here, numerator is more than the denominator. I will split it up like 16 plus 39 plus 19 over 30 over 30. 30 over 30 again I can split up to give me a value of 1, which will be added to 16. That means the integer part would become 17 and I'll be left with 19 over 30. Now let's come to a very important part, which is decimal place value. Let's take a number 854.0697532.418. Now every digit has a place value associated with it. If I look for the numbers before the decimal and after the decimal. Now if I start with before the decimal, the last number that I have, the last digit that I have is known as ones or units digit. The second last is tens digit. Third last hundreds. Fourth last thousand. This one you can call it as 10,000s. Lakh. 10 lakh is also called as a million, followed by crore, 10 crores, 100 crores, which is actually a billion. A billion is equal to 100 crores. And the digits or the place value after the decimal point would be different. The first one will not be units, it will be tens. This is tens, this is tenths. So there is a difference. This is hundreds, this is hundredths. 1 by hundredth. Thousand, this will be into thousand, this will be divided by thousand. So this will be 1,000th part, 100th part, 1/10th part. So there's no units or ones part. It will be tens, hundreds, thousands, ones, tens, hundreds, thousands, 10,000, lakh, millions, crores, 10 crores, 100 crores, which is also equal to a billion. So you have to remember this in mind, that if you go on the left, the place value increases. This is very different from a number line. On the number line, on the left hand side, the numbers are actually lesser than the numbers on the right hand side. The more the number is on the right hand side, the greater is the value. However, in case of decimal place value, the more the number is on the right hand side, it will have a lesser value. And in case it is after the decimal point, it will have even lesser value. 10 raised to power 3 would be 1000. 10 raised to power 5 would be 1 lakh. 10 raised to power 7 would be a crore. Now if you look at it, 10 millions is actually equal to a crore. And 100 crore is actually equal to a billion. And a trillion is 10 raised to power 12. Let's look at the question related to decimal place value. If twice 4632 is divided by 100, what is the 10th digit? Now the question is not asking me tens, it is asking me tens digit. That means it will be, if the answer comes out to be this dot this, it will be this digit, that will be my answer. So what I am doing, twice of 4632 is divided by 100. So you can do the actual multiplication if you want to, as calculator is available to you, or you can cancel some things out and it will be only 4 4632 divided by 50. So if you can actually divide this numbers, very good. If you cannot actually divide this numbers, there's actually no need in this exam because calculator is available to you. So if you just use the calculator and if you solve 4632 divided by 50, the answer that you will land up would be the answer that you want. So which comes out to be, you solve this number, this comes out to be 6. So the answer for this question would be 6. Let's look at another question. If 617 is divided by 49, so divide 617 with 49, and if 6, the answer that you will get would be 12.59. The sum of the tens and the tens digit. So this will be ones, this will be tens. Tens digit is 1. And tens digit is the digit which is immediately after the decimal value, which is 5. Now you have to find the sum. The sum adds up to 6. The answer for both the questions on this slide is 6. Now, what I told you is, if a number is recurring decimal, it is actually a part of rational numbers or it is actually a part of fractional. So recurring decimals can be converted into fraction. Only if it's a non-recurring and non-terminating, it cannot be written in a fractional form because it's an irrational number that we have. However, if you have a recurring decimal 45, that means it is 1 to 454545. It repeats, it can always be written in a fractional form. How to do this? Let's look at an example. So let the value of x be 0.12454545. The first step that I have to do is, I want only the repeating part after the decimal. So the non-repeating part has to be brought before the decimal. So I'll multiply this with 100. I'll have 12.454545 and so on. So this is the first step. That means after the decimal, there has to be only the repeating part. Non-repeating part should be before the decimal value. The second step would be, I would be multiplying the left hand side with the number of 1 followed by zeros, which is equal to the number of digits in the repeating part. So there are 2 digits in the repeating part, and I will be multiplying the left hand side again with 100. So that means 1 followed by 2 zeros, 100. So left hand side becomes 1 0 0 0 0 10 raised to power 4 x, and the right hand side is 1245.45.45. So this is the second step. What I have to do in the second step is, whatever is the recurring part, I'll have to bring it once before the decimal. Now if I subtract this, the right hand side would only be an integer. The fractional part would be cancelled out and I would get my answer. So I just cancel out the common parts and the final answer that I am left with is this one. Again, going back to integers. Integers were the part of real numbers which had no decimal value associated with it because the denominator was equal to 1 in this case. So integers could be negative, could be positive, and the case of 0 that I have to look at it. So if I want to classify integers, integers could be classified as even and odd. Even means integer which is expressed in the form of 2n, where n is also an integer. So that means every number, let it be either negative or positive, which is a multiple of 2. That means the remainder that it gives when divided by 2 would be 0. So every integer which is a multiple of 2 is termed as an even integer. And every integer which is not a multiple of 2, that means when divided with 2, it gives a remainder of 1, would be termed as an odd integer. So they are expressed in the form 2n plus 1 or 2n minus 1. where n again has to be an integer. So multiple of 2, even, not a multiple of 2, odd. There's certain rules that you have to adhere to when you are doing questions related to integers. The first one being odd plus odd or odd minus odd would always be an even number that I will have. So for example, 9 plus 3 is 12. 9 minus 3 is 6. Even plus even or even minus even is always even. So if you add two similar numbers, one odd, one even, or if you subtract two similar numbers, one odd, two odd or both even, you will always get an answer which is even. But if you take one odd and one even and you add them or you subtract them, the answer that you will get would be an odd number. However, if you are multiplying, it's a little different game. Odd into odd will always be odd. So this is 5 into 3 would give you an answer which is 15. Even into even would always be even, and odd into even would also be even. An even number multiplied with anything, let it be odd or even, would always be even. Even multiplied by anything is even, odd into odd is only odd. Let's look at an example basis upon the thing that we've just studied. The integer a is even and the integer b is odd. For each of the following integers, indicate whether the integer is even or odd. The method that I suggest you to take is always assumes the value. Assume the value all the time. So a, you take it as 2 and b, you take it as 3. Now what is the question asking you? A plus 2b. So this will be 2 plus 2 into 3. This will be 6 and 2, 8. My answer would be even. 2a. If I just do it conceptually, even multiplied with an even number would always be even, plus odd. Even plus odd would be an odd number that I have. Or I'll take the values and get to my answer. A into b. This is 2 into 3. Even into anything would always give you an answer which is even. An even number raised to power anything would also give you an answer which is even. Even number raised to power anything, even number multiplied with anything would give you an answer which is even. This is even plus odd. Even plus odd is odd. Odd into odd. Square means we are multiplying the numbers. Odd into odd would always be odd. However, if I do it with an example, 2 plus 3, 5. 5 square is 25, which is odd. A square minus b square. 4 minus 9, which will be again an odd number that I have. Or this can be worked with the formula as well. A plus b into a minus b. This will also be odd. This will also be odd. Odd into odd would always give you an answer which is odd. Let's look at another example. W, X, Y, Z are consecutive odd integers such that W is less than X, less than Y, less than Z. Which of the following statement must be true? Indicate all such statements. Again, the method that I would prefer would be assume the values 1, 3, 5 and 7. When you're multiplying odd numbers, the answer is always odd. So this is correct. Even without multiplying, you know odd into odd is always an odd number that you have. Now, what is it? Odd plus odd would give you an even answer. Odd plus odd would also give you an even answer. And even plus even would give you an even answer. This statement is incorrect. However, if you want to try with an example, you can also do that. This is 4 and this is 12. The total answer that you would get would be 16, which is not odd. W plus Z, so this is 1 plus 7, and X and Y, 3 plus 5. This is also 8, this is also 8, they are equal. This statement is true. So statement number 1 and statement number 3 are correct, whereas statement number 2 is a false statement. Let's look at another question. The question is, A and B are positive integers and A minus B is even and A over B is also even. Which of the following must be odd? If I just look at it, A minus B is even. Subtract. If I'm subtracting two numbers and the answer is coming out to be even, that means Either both of them are even or both of them are odd. So it could be the case something like, this is 6 minus 2, or this is 7 minus 3. So either A and B both are odd or A and B both are even. And what is given? A over B is also even. That can only happen in the first scenario. So that means A is also an even number that you have. B is also an even number that you have. Both are even. Which of the following must be true? Now, an even number divided by 2. An even number is always divisible by 2. Which of the following must be true? Now, this B, if I'm saying must be odd, I am not sure about this value. Why? Because if I look at it, I can take the value of B as 2 also. I can take the value of B as 4 also. So 2 divided by 2 is 1, which is not even, whereas 4 divided by 2 is 2, which is even. So I'm not sure about this statement, so I cannot answer this statement. Whereas if I look A plus B, this will be again even. Even divided by 2 can be even or odd. That means if the sum of A plus B is coming out to be 8, divided by 2 would give me an even answer. But if A plus B is coming to be 6, which can be 4 and 2, so 6 divided by 2 is an odd answer that I have. Again, this statement I'm not sure about. This statement can be even or odd depending upon the values of A and B. Let's look at this. Now I know A is what? A is even. Even plus 2 divided by 2. So if I take the value of A as 4, 4 plus 2 divided by 2, which will give me an answer of 3, which is odd. Even if I want to split it up, this will be A by 2 plus 1. 2 by 2 is 1. This will always give me an answer which is odd. So option number C would be the answer that I have. Another classification of integers is on the basis of negative, positive, or 0. So if I look at it, negative integers start from minus infinity and they go up to minus 1. Minus 1, minus 2, minus 3, minus 4. And non-negative integers. Non-negative means 0 or positive. So if I have to look at a non-negative thing, non-negative could be a case of 0, which is a neutral case, or positive. Positive integers are also known as natural numbers. So plus 1, 2, 3, 4, 5 goes on up to plus infinity. All of these positive integers are also known as natural numbers. Whereas non-negative integers are known as whole numbers. So whole numbers start from 0, go up to infinity. I can classify them as 0 and positive. So integers would be negative, would be positive, and would be 0. This is negative, so the rest of them would form a part of non-negative. Let's look at some of the questions. The product of two numbers A and B is negative and that of B and C is positive. What will be the product of A and C? Two numbers A and B is negative. That means one of them has to be negative. Either A can be negative or B can be negative. And that of B and C is positive. Now, B and C, the product is positive. That means it can be the case where when B is negative, C is also negative, and when B is positive, C is also positive. So it depends upon. Now, if B is negative, that means A has to be positive because I have to make their product also negative. If B is positive, A has to be negative. Then what will be the product of A and C? Positive into negative, positive, negative into positive, negative. So the product of A and C would always be negative. Always, in both the situations. The next question that we have is, if multiplication of two numbers A and B is greater than 0. So that means A and B is greater than 0. That means if A is positive, B is also positive. If A is negative, B is also negative. And A is less than 0. So this is all anyways given to us that A is negative. That means B also has to be negative. Which of the following must be negative? B always have to be negative. My answer would be option number A. Let's continue with what we were doing. We were talking about integers and we have looked at positive integers. Positive integers were called as natural numbers. 1, 2, 3, 4, so on up to infinity. Now these natural numbers can be classified further as prime numbers or coprime numbers with an exception of 1 or unity. 1 is neither a prime number nor a composite number. So natural numbers can be classified as prime or composite with an exception of unity. A prime number is a number which has exactly two distinct factors. One and the number itself. So it has exactly two distinct factors, one of the factor being 1 and the second factor being the number itself. So the prime number starts from 2, 3, 5, 7, 11, 13 and it goes on. 2 is the only even prime number. There's no other prime number which is even. And the smallest prime number as well. Only even prime number and the smallest prime number that I have. 3 being the smallest odd prime number. There are 25 prime numbers between 1 and 100 that I need to remember. And numbers which are not prime are known as coprime numbers. So I would say they have more than two factors. More than two factors. So all the other numbers which have more than two, or I should say a minimum of 3 factors, would be composite numbers. Numbers like 4, 6, 8, 9, 10, all of them would be termed as composite number. Let's look at some of the questions related to now prime and coprime. A natural number is multiplied with a prime number. So I have a prime number and I'm multiplying it with a natural number. The product is always a. So I'll have to look at various cases. Now prime number, I can assume the prime number to be 3. If I multiply prime number with a natural number starting with 1, I do get a prime number. But if I multiply this with 2, I get a composite number. 3 into 3, again a composite number. 9. So I'm getting a prime number in one case, I'm getting a composite number in the other cases. So that means it depends on the situation. I cannot get prime number in all the cases because the question says always. I cannot get a composite number in all the cases because I'm getting a prime number in one of the cases. And I'm not getting irrational numbers. So that means the answer that I'm getting in all the cases are actually whole numbers. So my answer would be a whole number. We hope you have enjoyed this video. Please like our video and subscribe to our channel on YouTube. You can visit our website edusathi.com to practice more questions on this topic and access other useful information. Like us and follow us on Facebook and Twitter to get exam related information and other such updates. We wish you all the best for your preparations. Thank you and have a good day.